So, good morning, everyone. Today in this presentation, I'm going to introduce what model merging is, and we are going to look at the most popular algorithm like spherical linear interpolation, ties, air, pass through, and also we'll go through the Colab example of how model merging is done using a merge kit library, and then we will learn on how proxy tuning is work. Okay, so model merging algorithm are implemented in an open source library called merge-kit. Okay, so what is model merging and how does it work well? Hopefully, so I'm going to tell going to answer all that. So as we know, trying to build the one great model that works best for a particular use case is not very easy. It takes time, it takes many iterations, probably many different fine tuning or alignment of data sets, and certainly it takes time, and also it takes compute and energy also. So we keep trying to improve the model, so it quite a bit of effort. So, and if you need to do this again and again for each project, then this is can be difficult. What we can say, this can be difficult to scale. So something different is required, and that's what model merging is about. It's trying to finding another way to build a high quality models. So the basic idea is, uh, we have many good models out there. We can find on all kind of data sets. So chances are that the abilities that I need from my model are present out there, and maybe they are present in different models, or maybe one model can summarize documents, maybe another model can translate healthcare documents. Maybe I need both. So maybe I want to build those different ability in my model. So instead of trying to fine tune a single model on different data sets and trying to teach it different things, can I do this from existing models? And that's really what model merging is about. We are going to try and identify good models that know things we are interested in, and merge them into single one, hoping that the merge model retains all the goodness present in the source models. So that's what model merging is about, trying to combine several task specific models into a single model that we hope will be multitask, and we are going to do this without any kind of training and fine tuning. So this will be purely be a mathematical operations where we take the weights coming from those different models and merge them using a particular algorithm. So this is not an what we can say. So this is not an ensembling technique. And ensembling means we have a collection of models that predict in parallel, and then we do kind of either averaging or fine tuning on the output, etc., etc. So here we do start from several models, but at the end there is only one model left. So the good thing about merging is there is no training involved, there is no fine tuning involved. We need a tiny bit of compute, and everything runs very nicely on the CPU. So it is a very lightweight process. It's fast, and merging doesn't take a whole bunch of CPU cores. So we can run this in maybe a few minutes, or it depends on the model size on our local machine. There is no extra cost of training. So let's move on. Slurp. So slurp means spherical linear interpolation algorithm. So in this so this algo was originally uh, designed for computer graphics to find the smoothest path from camera rotation. So let's imagine a camera rotating around a scene. So what is the best smoothest path from position A to position B? So for this purpose, they have derived this algorithm. In I think it is derived in 1985. It is a very old algorithm. So Slurp only works with two models. Why? Because we are going to transitions from one to the other other. Okay, so if we need to merge more than two models, then slurp is not an option. Yeah, yes, we can favor one of them. As we will see in later example, there is a parameter that we can set according to our needs. So the benefit of slurp is it helps the preserve magnitude of weight, because when we do average, we could have a very large weight in a model, and we could have a very tiny weight in another model. And when we average these two model, we'll have kind of the middle value that's not quite as good as uh, what we wanted. So that's one problem. The second problem we can see uh, in this diagram. Assume linear averaging is going to be a red dot, and we are going to do spherical interpolation, that's a blue dot. And so it's preserve the shape of the embedding space. And we know embedding dimension is means what we can say, embedding dimension is impossible to visualize. So try to visualize in 3D, or imagine we know merging values. So coming from two spheres, we know that we know that what we want in the end is still something like a sphere, and that's what slab algorithm will bring you. So if we look at this diagram, imagine P1 and P2 are two embeddings here, two vectors pointing at different parts of space. If we do the linear averaging thing, uh, which is a basic average, it is so that average will be going to be PL for linear averaging. So we can see, we know the magnitude is very different here, because, and we can see the curvature of the overall structure, or the, we can say, shape of the embedding space is changed. It's not so much sphere now.
Um,
So yeah.
uh, I was just asking if there is a formal definition of defining the curvature of this embedding space.
Mhm.
I mean, is there a formula, or how exactly is it defined?
Yeah, I will in next slide we will have
Okay.
the means pseudocode I have, we can understand from them.
Oh,
So okay, so this pseudocode is from the merge kit repository. So let's see how it works. So in this drawing, we are trying to average v1 and v0. Okay, so first of all, we need to normalize them. Then we find the angle between v0 and v1, and first we compute the dot product and find the angle theta, this green angle. And now we need to find the average vector that stays on the circle. So that's where we can favor one model or
Ritesh,
the other. Yes.
Ritesh, sorry to interrupt. Like, I just wanted to clarify कि जो x-axis और y-axis पे क्या है? Like, what features do we have? Like, जिसके बीच में we are
भैया
trying to
आपकी
find
आवाज़
this
प्रॉपर
theta.
नहीं आ रही है.
Okay. So, मेरा question ये है, like, is it fine now?
हाँ हाँ.
हाँ. So the x-axis और the y-axis, what are those like those features?
It is a
Like
vector
v0 और
embedding,
v1,
भैया. Yes.
vector embedding of
Vectors,
like
vector
what,
space we
like
can say.
tokens or
Model
the
means
vector of like.
yes.
Oh, अच्छा.
Okay. So okay. So we need to find the angle between v0 and v1. So here we can favor the one model or other. It is a t parameter, or let's say if t is 0 0.5, then we will be in the middle. But we can favor this according to our need, v0 or v1 we want. So if we compute the new angle, this the middle ground angle using the t parameter. So v0 to new vector is going to t theta and new vector to v1 is going to be 1 minus t theta. Again, if t is 0.5, then we are in middle. So once we figure out the direction of that new vector, then we just apply that t theta angle to figure out, and we use the original vectors, then simply normalize vector. So to compute the new vector, so to compute the new vector, so that's the basic idea of slur. Uh, I will also, so it is very simple. We can see from compute perspective, it is a really lightweight, just a tiny bit of trigonometry, but all that stuff will run will run nicely on CPU. Also, we'll
Ritesh, I have one question here. So
yes, sir.
when I'm saying V1 and V0, so are they coming
Hmm.
from two different models?
Yes, sir.
Okay, and we have to pick one of them.
No, 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 no.
Mhm.
We are just, sir, averaging using like a trigonometry function. Means
No, no,
uh,
no, that is okay. But at the end, what is our objective? So you said that when we merge different models, finally
mhm.
we get just one model,
Yes,
right?
yes, 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 yes. We
So
finally we will get one model.
so in this case, like V0 and V1 are some outputs of those different models, right?
Yes.
So are we going to choose one of them, V1 or V0?
No, no. We will choose both. I will explain you the in a collab file where we can have a config file. It will very easy to understand. Means we can choose how many part we want from one model or second model, or we can also choose which model we want to for our base model or primary model. Also, we
Okay,
can
sure,
set.
sure, sure. Okay, sure, sure.
Yes.
So I have a question. So this whatever we are doing is just for to get a middle ground between both of these models, right?
Means so our now our goal here, the goal is to that our vector space is should not be linear. Means if we can direct average the vector and divide, means if we direct average, which is very straightforward, then it will not in the direction, means spherical direction or the direction of the vector embedding. So that's why we are doing spherical. Before this algorithm, there is a linear algorithm, so which simply divide, means average the vector and combine the models. So here we are doing circle, means spherical of vector.
Ritesh, so if
Huh?
V0 and V1 are coming from like two different
Different.
embedding spaces, तो
Yes.
actually like why would this like जो भी ये थीटा से रोटेशन है या एवरेजिंग है, why would it make sense? Because V1 actually like when we project it to the V0 का embedding space, uh, are we doing some sort of projection पहले, या are we just directly taking V1 and V0 independently like उनके values and then doing this?
दी आई डोंट थिंक सो, मीन्स मुझे कंप्लीट पता नहीं है कि एग्जैक्टली क्या हो रहा है। जस्ट मैंने ये सूडो कोड वहाँ से लिया था, बट हाँ ये ऐसा हो सकता है क्योंकि ऑल्सो मीन्स क्या बोलते हैं इसको, V1 एंड V0 जो है सेम आर्किटेक्चर सेम होगा दोनों का, मीन्स सो देयर शुड बी सेम आर्किटेक्चर ऑफ बोथ द मॉडल्स वी आर मर्जिंग।
हाँ मतलब अगर आर्किटेक्चर इवन इफ द आर्किटेक्चर इज सेम, तो जो एम्बेडिंग डायमेंशंस है वो तो एकदम ही डिफरेंट हो सकते हैं, राइट? सो इट्स पॉसिबल कि V1 वेक्टर जो कुछ इवन एम्बेडिंग स्पेस में है, if we take those absolute coordinate values and try to present V0 sorry E0 वाले एम्बेडिंग स्पेस में, it might end up at something very different, right? तो
हाँ
even
हाँ
take average V0 and V1 का, then मतलब it won't make sense, right?
Yes. So मुझे मे बी they are projecting it in same what we can say that you are saying before the doing this algorithm, before the applying this algorithm.
अच्छा.
Yes.
And you said this algorithm was used for ऐसे interpolating camera images क्या?
Yeah. In first it derived for that thing
अच्छा.
in starting.
And
Yes.
have people also used it for model merging क्या? Yeah, this is just like very
Yes.
old work.
What?
मतलब सिर्फ ऐसे कैमरा मर्जिंग में ही था यूज एंड देन पीपल, और डिड पीपल एक्चुअली स्टार्ट यूजिंग इट फॉर लाइक मॉडल मर्जिंग?
या हाँ, मॉडल मर्जिंग में यूज़ कर रहे हैं, मतलब अच्छे अभी जो मॉडल फर्स्ट जो इम्प्लीमेंट करा है इस लाइब्रेरी में, फर्स्ट एल्गोरिदम ही यही थी जो इन्होंने इम्प्लीमेंट करी थी, इस मॉडल मर्ज की जो लाइब्रेरी है, और इसको यूज़ कर रहे हैं और एक्चुअली ये वर्क कर रही है।
अच्छा, ठीक है। डू यू ऑल्सो हैव सम एग्जांपल्स क्या स्लाइड्स में टू शो ये, मतलब
कैसे
कैसा?
मर्ज होता है ना?
हाँ, कैसे
हाँ
कैसा
हाँ हाँ हाँ,
perform-
वो कोलैब नोटबुक है, मैं उसको दिखाऊंगी कि मर्ज कैसे करते हैं, सिंपल कॉन्फ़िग फाइल है और ये सब।
ठीक है, ओके।
Ritesh,
हाँ
so I was just it's like छोटा सा doubt है. So suppose कि मेरा एक model है जैसे Mistral kind of model, right? Like which is
मिस्टर,
like
हाँ
some
ठीक है।
experts, yeah, Mistral.
हम्म
And suppose मेरा दूसरा जो मॉडल है Llama 3,
हम्म
तो like दोनों अपने अपने टास्क पे अच्छा परफॉर्म करते हैं. So how will I
हम्म
merge them? मतलब वो थोड़ा सा like अगर आर्किटेक्चर ही पूरा का पूरा चेंज है, but still like will be able to merge them.
नो, इस एल्गोरिदम में हम नहीं कर सकते। अब
अच्छा.
अभी लास्ट में अभी एक एल्गोरिदम आएगी, पास थ्रू एल्गोरिदम बोलते हैं उसको, उसमें हम कर सकते हैं।
हम्म. अच्छा अच्छा, श्योर श्योर.
ठीक है। So next one is called ties. So ties is a bit different. So ties starts by noticing that there is a problem when we merge models using uh, what we can say slurp algorithm. So there is thing called parameter interference. So they highlight two major problem. The first one is what they call the influential versus redundant parameter. So let's say in we have two model, and in one model, let's say the parameter is actually highly influential. So maybe it has a larger magnitude, and the other model uh, has a really low magnitude. So when we actually merge the uh, two, then we kind of cancel the influence of the parameter in model one. So that's a problem we have. Uh,
Um,
the other problem
hello,
is
hello,
yes.
Ritesh.
Hmm.
What is magnitude refers here?
So magnitude refers to the size, or we can say strength of parameter within the model.
Okay, okay.
Okay. So other problem is here is sign conflicts, where some parameter could be positive and their equivalent parameter in other model could be negative again. So again, adding these two can be cancel things out. Okay, we can see an example from this paper. So in this diagram, we have three things. So the left one with square shape is fine. For example, here we have a two pink and purple parameter with the same magnitude about the same sign. We can assume if it is a arrow is upward, we can say it is a positive. If arrow is downward, so it is a negative. Uh, so here magnitude is the same sign. So when we merge them, that's okay. We can get something that work. In the middle, we have the round shape. We have a very tiny pink parameter saying it has a low influence, and then we have a much more important influential purple parameter. And again, if we just average these two, we get something that's kind of cancelled out. And then in third, with the polygon, we see one parameter is strongly positive, the other one is negative. And again, if we just averaging things out, we get something with a low magnitude, and probably we destroyed the strong influence of that uh, large purple parameter. So that's what ties is trying to solve. So so ties means
सॉरी, आई थिंक आई मिस्ड इट। तो ये जो वैल्यूज हैं, दीज आर इंडिविजुअल पैरामीटर वैल्यूज और दीज आर सम एम्बेडिंग्स फॉर सम टोकन?
we can assume it is different embeddings of a model.
अच्छा, एंड व्हाट इज इंटरफेरेंस, ये जो ऑपोजिट डायरेक्शंस में है,
Mhm.
मतलब ये कुछ n dimension में कैसे translate होगा?
There is no n dimension thing in this means there is I'm just creating intuition that paper has showed means we can have negative magnitude of vector and positive magnitude of vector, so they are trying to uh, explain this thing, means they are just removing the non-influential redundant parameter from that model that we are going to merge.
What is a redundant parameter?
Redundant parameter means for example there is very low influence, or for example here we can say it is a very tiny parameter, so if we average these two parameter, so it will affect the final result. So what we can do, we just eliminate this. So how they are eliminating, I will explain in next slide.
But this is a parameter.
Yes.
Okay, so this is not actual embeddings. This is
Yeah,
parameter.
this is a parameter of, for example, this pink is a model 1 and purple is a model 2. Model 2's parameter.
ठीक है, okay.
So just one thing. Can you go back to the previous slide here? So redundant means parameters. Maybe they are just there in the model, but they don't have any effect on the output. That is what I think means by
Yes, yes.
redundant, right?
Yes, sir.
Okay. And when I say, and what do you mean by interference between two parameters?
Means one is negative and one is positive, like that.
Okay, no. If you see the last line of the caption, it says the parameters causing interference are denoted by dotted arrows. Right. Now you see the second one here. So
Yes,
second
yes.
one, right? So there they have the same direction.
Oh, sorry. So here they want to means what the sign is same for those parameter, means those are positive, but one is very tiny or small and one is very large. So if we average this, average those parameter, so it will be in there something in middle. So there is no importance of this parameter, but it will be if we merge it, so it will influence our final result.
See, there are three definitions. One is influential, one is redundant, one is interference, right? So seems like you're mixing redundant and interference together. Like, so what is the exact definition of interference?
It just means there is so if we say no interference means they are okay, means there is no interfering those or our results, because
No,
with
other idea could be that maybe if suppose the same parameter in the
Mhm.
two different model, one is responsible for predicting the label as positive, the other one is responsible for predicting the label as negative, right?
Mhm.
In that case, these two are interfering with each other's,
Mhm.
right? Weights can be positive or negative. One weight could
Yes,
be positive, or both could be positive, or one of them could be negative. That is possible. So I think
yes.
that is how they might have defined this interference thing.
Sir, then they won't be giving the sign conflict then. If one weight is positive and another is negative,
Mm.
No,
it
so this
can.
is no, so this is one type of an interference. One type of an interference that can
One
happen.
type of.
Yes.
Yeah, so there can be different ways in which two weights can interfere with each other. One could be where the signs are same, one could be where signs are different.
Sir,
Right?
I
Now,
don't understand how do we define that they are giving different labels?
I don't know. So that is what I just want to get confirmed. Right. So that could be one potential definition of interference.
अच्छा. हम्म.
Maybe they
Okay.
are just vectors, right?
Yes. Okay, I will check and let you know.
Okay.
So
Sorry, Ritesh, what is mean and ties in this ये second वाला diagram?
what the
ये mean and ties जो दो
where is
orange and green
ये
है.
भी ये भी नेक्स्ट स्लाइड में समझा जाएगा, वो आगे की स्टेप है.
अच्छा, okay.
So So ties means trim, elect, sign, and merge. So let's try and break things out. So let's go from left to right. So in the first test vector box, we see there are three models being merged. Okay, so there is the pink one, purple one, and we can say yellow. Three models. Okay, we can see we have a very different configuration. So we have five sets of parameter here: one, two, three, four, five that we want to merge. So the first step is to trim each. So the first task or first step is we first trim each group of parameter that we are going to merge to keep only the to keep only the influential parameter. So what that really means, we are going to discard the parameters that have a really small magnitude. So we can see in the second box called trimmed task vector. The first group of parameter we eliminate the purple and the yellow parameter because they were very small compared to the pink ones. Same for group number two, we only kept the large yellow parameter. For group number three, we'll eliminate the small yellow parameter. For group number four, we didn't trim anything, and in group five, we trimmed the purple and pink parameter. Okay, so we drop the smaller value, and that's a parameter we can control. Okay, so now we eliminate the redundant parameter. So the second step is to figure out the signs. So for each group of parameter, we need to decide if we want to stick with positive values or negative values. So that's the elect sign path we can see here. So the first group parameter is very simple. We only have a positive, only left, so only positive. So the sign will be positive. Same for the second group. In the third group, we have a uh, large negative and a purple parameter. So so overall the sign will be here negative because the largest magnitude comes from the negative purple parameter. In fourth group, it is a positive because we know we tend to go towards the positive more than the negative. So in last group five, there is only one parameter, so it's a easy choice.
So Ritesh, are
So
we going
once
to choose the sign always based on the magnitude? Because if that is the case, then why do we took these multiple arrows in the second step, in the first step?
here,
No, so see the first step after trimming,
yeah, okay,
the second last parameter, it has all the three arrows, right?
second, yes, here. Hmm.
Right. Now, if we in the second step when we have to elect the sign, if we have
Hmm.
to always choose that value which has the highest magnitude, right?
Hmm.
Then why
Hmm.
do we need to choose these three in the first step?
So in first step is just a trim. We need to trim. So in second step we can they are doing electing the sign.
Okay, fine. Go ahead. Maybe there's something more. Okay, please.
Yes. So once we have the sign vector, then we are going to eliminate the parameters that don't have the right sign. So for the third group, we eliminate the pink parameter, and for the fourth group, we eliminate the pink parameter again. And then we so after so here we eliminated the parameter according to the sign. So after this, then we merge whatever is left and compute the average. Uh, so that's the basic idea to get rid of the non-influential parameter. So finally, we add those average parameter to the original model, and also there will be a scaling factor again. So we can decide how much we want to influence the
What do
old.
you mean by aligned values?
So there is only step where means in this step we are eliminating the signs according to signs and giving the final touch, we can say,
No, but
for
if you see the violet color arrow, that is still there in
this.
the this one.
Because I think because it is a not influencing that much in our because it is a positive also, and so we can have it.
ओके फाइन, ठीक है।
रितेश, ये साइन में आर वी जस्ट टेकिंग सबसे बिगेस्ट वेक्टर का मैग्नीट्यूड, या जैसे फॉर
Yes.
एग्जांपल ये जो फोर्थ
हाँ,
ग्रुप है, तो
fourth
इसमें
group.
वी हैव थ्री
Yes.
वेक्टर्स, तो ये हम येलो और पर्पल को मैग्नीट्यूड ऐड करेंगे एंड देन विल कंपेयर इट विथ जो भी नेगेटिव्स वाले हैं। नो नो, आई एम आस्किंग कि मतलब सिर्फ येलो को लेकर के हम पर्पल पिंक से कंपेयर कर लेंगे, या विल वी
नहीं,
ऐड एंड देन
यहाँ पे दी ओनली जो लार्जर और लार्जर से ही कंपेयर कर रहे हैं साइन कैंसिल आउट करने के लिए।
अच्छा,
Yes.
तो जो सर पूछ रहे थे मतलब, तो इफ वी जस्ट वांट टू टेक द साइन देन वी कैन टेक सबसे हाईएस्ट मैग्नीट्यूड वाला, एंड दिस वेटेड
Yes.
एवरेज के लिए वी आर टेकिंग मल्टीपल वेक्टर्स। अच्छा,
Yes.
एंड व्हाट इज द कंटेक्स्ट ऑफ कॉलिंग दिस एज टास्क वेक्टर?
It just a task vector means the parameter that we want to merge. So that's just they call it a task means our we can say that this parameter we want to merge simply. They just say that because we can choose the layers or parameter in merging process.
अच्छा, एंड इसमें ये जो पैरामीटर्स हैं, ये इसमें वो डिफरेंट मॉडल से कौन सा आ रहा है वो कैसे पता चलेगा हमें? अच्छा, मॉडल।
एक्चुअली इसमें सेम अच्छा डिफरेंट मॉडल्स हैं, तो यहाँ पे हमने डिफाइन करा है ना कि कौन सा मॉडल है।
हाँ हाँ, कलर्स, ओके, ठीक है। एक सॉरी, एक सेकेंड, एक बार वो कैप्शन दिखाओगे क्या?
हाँ,
ओके।
हेलो रितेश,
यस।
हाँ, कैन यू गो टू दैट साइड? अच्छा, ये जो सेकंड में था राइट, जहाँ पे हम पर्पल येलो और पिंक ले रहे हैं राइट, और जहाँ पे ये सेकंड इलेक्ट्रिक साइन है, तो जो फोर्थ वाला है तो उसमें हम जो पर्पल और पिंक कैंसिल आउट कर रहे हैं, फिर जो अलाइन वैल्यू में है हम उसको लेके फिर डिजॉइन कर रहे हैं, ऐसा क्यों? रीजन क्या है इसमें?
मैं पहली पूरी बात तो तुम्हारा समझा नहीं, तुम एग्जैक्टली
हाँ,
कहना चाहते हो।
जैसे अभी क्या है कि हमारा ये सेकंड जहाँ पे ट्रिम टास्क बेटर है राइट, तो उससे दो
हम्म
चीजें निकल रही हैं, एक अलाइन वैल्यू और दूसरा इलेक्टेड साइन। तो
हम्म
इलेक्टेड साइन में हम क्या कर रहे हैं कि एक पर्पल और ये
साइन।
पिंक,
हाँ।
हाँ,
हम्म
पर्पल और पिंक को हम एलिमिनेट करके जो हाईएस्ट वैल्यू है वो ले रहे हैं राइट।
हम्म हम्म,
अलाइन में हम तीनों ले रहे हैं जो फोर्थ में है, फिर उसको हम दोनों कंबाइन करके डिसजॉइन कर रहे हैं। तो इससे कुछ मतलब वैल्यू में फर्क आ रहा है कि कैसा?
एग्जैक्टली मैं पहली बात तो समझ नहीं पा रहा हूँ, बट यहाँ पे हम मर्ज इसलिए कर रहे हैं कि हमारा मेन टास्क ही मर्ज करना है।
ओके, तो दोनों अलग अलग वेट कर रहे हैं, क्योंकि अलाइन में हम बाकी भी ले सकते थे राइट, बाकी जो वेट्स हैं, फर्स्ट अगर फर्स्ट स्टेप पे देख रहे हैं, तो ये सिर्फ जो फोर्थ में है ना अलाइन वेक्टर वैल्यू में,
हम्म,
जो पर्पल और पिंक है, वो
हाँ ठीक
उसी
है।
में क्यों ले रहे हैं, बाकी में क्यों नहीं ले रहे हैं?
कैन एनीवन क्लियर द क्वेश्चंस प्लीज? आई एम नॉट गेटिंग योर क्वेश्चन राकेश।
अच्छा अच्छा, एक लास्ट है, जैसे अभी क्या है कि हम चारों, सपोज हम पांच ले रहे हैं राइट, पांचों वो वेक्टर्स
5
है
ग्रुप।
राइट। हाँ,
ठीक
तो
है।
उसमें क्या है कि सेकेंड स्टेप में हमने एलिमिनेट किया, सिर्फ हाईएस्ट वाला लिया राइट। और जब
हाँ।
हम फोर्थ में देख रहे हैं तो उसमें हम थ्री वेक्टर वो है, एरोज हैं, एक पर्पल है,
यहाँ पे।
येलो और
हाँ।
पिंक है, यहाँ सेकेंड राइट।
ठीक है।
तो अब
हाँ।
जब अलाइन वैल्यू में जा रहे हैं तो उसमें क्या कर रहे हैं कि हम उसको कंसीडर कर रहे हैं जो फोर्थ वन है,
हम्म,
और सेकंड में जहाँ पे इलेक्टेड साइन है उसको कंसीडर नहीं कर रहे हैं। पर अगर हम फर्स्ट स्टेप पे देख रहे हैं तो उसमें क्या है कि हमने हमको क्यों उसी को क्यों लिया, बाकी को क्यों नहीं लिया? बाकी एक कोई भी हम फिफ्थ को भी ले सकते थे ऐसा।
फिफ्थ को?
हाँ, फिफ्थ या फोर्थ को, या थर्ड को भी,
कहाँ पे कहाँ पे
या फर्स्ट
कहाँ
में
पे नहीं लिया?
इधर अलाइन वैल्यू में।
यहाँ पे सबको लिया है हमने, सारे हैं इसमें।
नहीं नहीं, जैसे अब हम इसमें तीनों एरो ले रहे हैं राइट फोर्थ में, बट बाकियों में सिर्फ मैक्सिमम एरो ले रहे हैं, ऐसा है?
हाँ, तो उसके लिए मुझे लगता है कि तुम पीछे की स्टेप भूल चुके हो, क्योंकि यहाँ पे क्या हो रहा है, जस्ट हम जिस मॉडल या जिस ग्रुप का साइन हमें हटाना था, वो जस्ट यहाँ पे शो कर रहे हैं कि वी कैन जस्ट एलिमिनेट दिस साइन।
ओके ओके।
अच्छा रितेश, ये कैप्शन में ऐसा लिखा है कि ये जो सेकेंड लाइन है कि दीज आर डिफरेंट वेक्टर्स प्रोड्यूस बाय फाइन ट्यूनिंग ऑन डिफरेंट टास्क, तो इस पेपर में ऐसा है क्या कि दिस इज ओनली फॉर फाइन ट्यूनिंग, लाइक बेसिकली मर्जिंग डिफरेंट फाइन ट्यून वर्जन्स ऑफ द सेम मॉडल, या विल इट आल्सो वर्क इफ वी हैव टू डिफरेंट मॉडल्स विद द सेम आर्किटेक्चर?
सेम आर्किटेक्चर होना चाहिए दीदी। ये इन्होंने जस्ट ऐसा बताया होगा कि वी कैन हैव डिफरेंट मॉडल, बट आर्किटेक्चर सेम होना चाहिए।
अच्छा अच्छा, ठीक है।
यस।
नंबर ऑफ लेयर्स डिफरेंट हो सकते हैं।
नहीं।
ओके।
Also, एक बार can you check बाद में after the presentation if actually like different pre-trained versions of the same architecture be merged using this technique, because absolute values के basis पे ही we are trimming and then creating these sign vectors, right? तो अगर pre-training में तो even if we train two different models on the same data set, we can end up in different embedding spaces, right? Because बहुत randomness होता है। तो maybe this might actually not work if we have two models which are pre-trained maybe on the same data set, same architecture, but they are like two different versions. If they are fine-tuned from the same pre-training task, maybe then this makes sense. But
Yes,
you
yes, yes,
can check
yes.
and then tell.
Yeah, I will check.
Thanks.
रितेश,
Yes.
लाइक जस्ट लाइक कि एक छोटा सा क्वेश्चन है। तो सपोज कि लाइक द ऑब्जेक्टिव ऑफ दिस मॉडल मर्जिंग इज लाइक वी हैव लाइक कपल ऑफ मॉडल्स एंड देन वी पुट ऑल टुगेदर इन अ सिंगल मॉडल, राइट? लाइक कि सबका नॉलेज सबसे आ जाएगा, राइट? या सो मे बी लाइक आई वाज जस्ट थिंकिंग कि लेट्स से अगर हम एक क्लासिफायर ट्रेन कर देते हैं एंड दिस आइडियल क्लासिफायर विल से कि जैसे लेट्स से कि अगर स्पोर्ट्स का कुछ क्वेश्चन आया तो मॉडल दिस विल गो टू मॉडल नंबर 1, एंड अगर सेकंड जैसे कि कुछ लाइक न्यूज़ का है तो दिस विल गो टू मॉडल नंबर 3।
ठीक है।
सो लाइक वी कैन हैव दिस क्लासिफायर के लाइक व्हिच रीडायरेक्ट्स कि अगर एक इंफॉर्मेशन एक मॉडल में
यस,
नहीं है
यस।
तो दिस कैन बी
हाँ, तो
फाउंड इन द
इसमें
अनदर
एग्जैक्टली
मॉडल।
एग्जैक्टली भैया वो कर ही रहे हैं अपन कि जस्ट वी हैव टू, फॉर एग्जांपल अगर अपना मॉडल एक जो है समराइज पे काम करता है, और दूसरा मॉडल जो हेल्थ केयर डॉक्यूमेंट को समराइज करता है, और दूसरा अपना लीगल डॉक्यूमेंट को समराइज करता है। ठीक है।
राइट।
सो वी कैन मर्ज देम एंड वी हैव बोथ द फैसिलिटीज इन वन मॉडल।
पर सपोज कि अगर जैसे कि लाइक मॉडल नंबर 1 टेक्स अराउंड लाइक 20 जीबी, राइट? और जो सेकंड
20।
मॉडल है 20 जीबी ऑन अवर जीपीयू सपोज,
ओके ओके।
एंड हमारा सेकंड मॉडल आता है वो लेता है दैट टेक्स अराउंड लाइक 15 जीबी समथिंग।
15
सो
GB। ओके।
या सो लेट्स से लाइक सम ऑफ द पेपर्स हैव टोल्ड कि लाइक लेट्स से कि अगर जो मॉडल मर्ज करने के बाद में हाउ मच स्पेस विल इट टेक, लाइक तो लाइक हैव पीपल शोन दैट थिंग कि
सो इसमें डिपेंड करता है। कि फॉर एग्जांपल आप बोल रहे हैं कि फर्स्ट वाला मॉडल, सो
हाँ
उसमें अपना
उसने
20
20
GB
लिया।
है।
हाँ।
सो अगर उसमें से हम अगर हाफ वेट ही लेते हैं, सो इट विल बी मींस, सो कम हो जाएगा उसकी साइज। सेम फॉर अदर ऑल्सो, बिकॉज वी कैन डिफाइन द डेंसिटी ऑफ मॉडल।
हम्म।
नहीं, वो समझा नहीं मैं।
सो मे बी लेट्स से कि लाइक मॉडल नंबर 1 ने लिया 20 जीबी, मॉडल
ठीक है।
नंबर 2 ने लिया 15 जीबी।
15 GB।
मॉडल
ओके।
मर्ज करने के बाद में हमें मिला लेट्स से कि हमारा हमारा मॉडल नंबर 3।
मॉडल नंबर 3।
हाँ, सो अब ये मॉडल नंबर 3 का क्या ऑप्टिमल साइज रहेगा ऑन अवर जीपीयू?
अच्छा, ऑप्टिमल साइज क्या होगा?
या
आई थिंक तुम जो बोल रहे हो दैट इज मोर लाइक अ मिक्सचर ऑफ एक्सपर्ट्स। आई थिंक ये वाले केस में तो वी एंड अप विद जस्ट वन मॉडल,
वन
बिकॉज
मॉडल, राइट? तो अब
यस,
M3 का
यस।
साइज क्या रहेगा?
So,
it would have the same number of parameters, ना? Same
यस।
size.
हाँ,
सेम
सेम
पैरामीटर्स
साइज।
फॉर अवर मॉडल M1 के हिसाब से लाइक 20 जीबी ऑन एन
Yes,
एवरेज इट विल
yes.
टेक।
Because we can give us a primary model, that it should be our primary model in
दोनों
parameter.
मॉडल के आर्किटेक्चर सेम है, सो पैरामीटर भी सेम होना चाहिए।
पैरामीटर भी सेम होना
हाँ,
चाहिए।
हाँ।
सो M1 और M2 शुड बी इक्वल साइज।
Yes.
फाइन देन।
So let's move on the next one. It is dare. So dare actually realize that when we run fine tuning, we do update a lot of parameter. but as it turns out, it looks like a lot of those updates are redundant, so they are useless. So
Ritesh, sorry,
yeah,
I'm sorry, मैं बीच में interrupt कर रही हूँ. Actually, I think I had some confusion. तो I was अभी तक तो thinking कि we are updating parameter, like merging ये, sorry, averaging ये parameter values, but these are vectors, right, which we are averaging.
yes, the vector space, yeah.
Oh, तो फिर I think then what
एक ही
Himanshu
बात है.
is asking, no,
हाँ.
it's not the same thing, no, because अगर हम different fine tune models के outputs को merge कर रहे हैं, then it's different, right? Because then we'll have to have दोनों मॉडल के पैरामीटर्स.
आउटपुट दीदी, जो आउटपुट का मर्ज करने वाला जो आप बोल रहे हो, वो थोड़ा प्रॉक्सी ट्यूनिंग का पार्ट होता है.
अच्छा, कैन यू गो बैक टू द पुराना वाला स्लाइड एक बार, बिकॉज
I think he's
यहाँ पे ये जो है वैल्यूज जो हम एक्चुअली मर्ज कर रहे हैं ये तो आउटपुट्स है, राइट? दीज आर टास्क वेक्टर्स. तो ये मॉडल के पैरामीटर वैल्यूज तो एक्चुअली मर्ज नहीं हुए, राइट? जस्ट द
नहीं नहीं,
आउटपुट.
पैरामीटर है दीदी, मीन्स इट इज अ वेट्स ऑफ पैरामीटर, मीन्स वी कैन से इट इज अ वेट.
इट्स नॉट.
बिकॉज तो आप जो बोल रहे हो ना, आउटपुट वाला, वो एग्जैक्टली प्रॉक्सी ट्यूनिंग में होता है.
बट यहाँ लिखा है, राइट, दिस इज टास्क वेक्टर.
हाँ.
वेट्स के भी वेक्टर्स रहते हैं ना, मतलब फर्स्ट रो सेकंड रो लाइक
बट
दैट.
बट वी वोंट कॉल देम टास्क वेक्टर, राइट? टास्क वेक्टर तो हर टास्क के लिए होगा डिफरेंट, या जो भी हमने फाइन ट्यून किया तो हर इनपुट के लिए दैट वुड बी डिफरेंट, राइट?
वो चेक करना पड़ेगा एक बार दीदी, क्योंकि
ठीक है.
सो
Shruti, Ritesh, if you go to the previous slide,
यस.
Shruti, just read here the the third sentence in this caption. That actually tells or kind of clarifies the confusion.
ओके, हाँ ठीक है सर. सो दिस इज पैरामीटर वैल्यूज, ठीक है.
These are the parameter values, but these colors are coming from different tasks on which the same model has been fine tuned on. Okay, and these are not the actual. I think these are not the actual value of the weights. These are the increments or the decrements.
सर कौन सा इंक्रीमेंट डिक्रीमेंट?
So I mean to say the updated weights. I think that is what the arrow depicts, the update
ओह
to a
अच्छा.
parameter. It is not the actual weight of the parameter. It is the update, right? The gradient value, alpha times gradient, the gradient value, I guess.
राइट, मेक सेंस.
Okay, so again, these are not two independent models. It is the same model fine-tuned on multiple tasks, which we want to merge now.
So maybe we are just taking the difference of the fine-tuned parameter values with the pre-trained वाले parameter values, and जो भी वो difference आ रहा है उसके basis पे we are computing the final parameters का average values.
Where are we doing this? Where are we performing this difference here?
I am thinking sir ये जो value arrows हैं, these are the difference.
No, these are not the difference. These are the update, the gradient values.
Sir, but gradient values तो बहुत सारे हो सकते हैं, right? Like every time we fine tune an instance, we'll have multiple gradient values.
So multiple gradient value for each parameter.
हाँ मतलब so if we are training fine tuning on say 100 instances, so every instance will have some gradients.
Yes. So I think they are merging for every instance.
Oh.
This is what it looks like. I don't know exactly, but either they are averaging over those 100 ones or they are merging it for each of the instance.
It could be just magnitude of those vector also. I mean the weights.
But here it is not talking about the magnitude. Here it is talking about the update to a parameter produced by
Yes.
fine tuning on different tasks.
आई थिंक सर वैसे कर सकते हैं, राइट? लाइक से अगर फाइन ट्यून कर लिया हमने, तो देन विल एंड अप विद सम न्यू पैरामीटर के वैल्यूज, एंड दीज आर द अपडेटेड वैल्यूज. प्री ट्रेन मॉडल में कुछ और डिफरेंट पैरामीटर वैल्यूज होंगे.
Then in that case, you take the difference, right?
हम्म.
Right. Yes. That is also possible. Yeah. But maybe the Ritesh is the best person to tell us what is the correct thing, how they have done it.
और
Yeah, I will check and let you know.
Okay. But you understood what we are saying, right?
Yes.
Okay.
also, how old is this paper, Ritesh?
ये I think ये 23 का ही है इसलिए.
अच्छा अच्छा, ठीक है.
Okay, so DARE means drop and rescale. So DARE uses a similar approach to ties with some with two main difference. So it is a very bit easy to understand. So we randomly eliminate up to what we can say. For example, we randomly eliminate up to 99% of the parameter updates. So we don't eliminate the parameter themselves. Means it's not a pruning. Okay, so but we eliminate the update. So we stick to the original weight of the fine tune model. Okay, imagine that we only keep 1% of those actual updates, and those updates are then rescaled according to how many we have dropped, because we have fewer updates, so they need to be impactful if we eliminate 99% of those updates. So, and then we rescale according to the factor of 100. So fewer updates, but very large updates, interestingly. So the more negligible the impact of dropping all the updates. So it's really a task vector compression or shrinking technique. So that means we can have a tiny task vector that we very easily or very quickly manage, and all other things are same uh, as a ties algorithm. In this algorithm, it just updation of ties algorithm. So the last one I will talk about the pass-through merging. So it's
Ritesh,
also,
again, can you go back to the previous slide?
yes.
So when you say third point, they randomly reset fine-tune weights to their original values, right? So that means the weights have already been fine-tuned, and now you are resetting them to their original value.
Means if you
So,
have for example,
so why are you doing this? Like, what is the benefit of this process?
मीन्स यहाँ पे इन्होंने ऐसा बोला कि एग्जैक्टली वी आर फाइन ट्यून मॉडल है, और उसको उनको हम मर्ज करना है. ठीक है, तो ये कहना चाहता है कि उसमें बहुत सारे पैरामीटर ऐसा होते हैं जो कि रिडंडेंट होते हैं. ओके, सो उन्होंने क्या करा कि टाइस जो कर रहा है वो ठीक है, बट हम कुछ दो चेंजेस और करेंगे, और दो चेंजेस ये है कि वो क्या करेंगे कि एलिमिनेट कर देंगे अपडेट्स जो कि रिडंडेंट है, एंड देन उसको कुछ फैक्टर से रीस्केल कर देंगे. सो जस्ट ये इन्होंने चेंज करा इसमें, ताकि और मॉडल के परफॉर्मेंस पे कोई इफेक्ट ना पड़े.
So that means we are not going to merge all the weights, all the parameters, right?
Yes,
We are going to merge
yes.
for some. Rest of them, we are going to keep them as it is, the way they were before. For fine tuning, right? Does this mean?
Yes.
Think?
Yes,
Okay,
sir.
fine.
रितेश, ये जो p परसेंटेज हमने ड्रॉप किया, दिस इज द सेम जो हमने वो रैंडमली रीसेट किए हैं क्या, या इज दिस?
हाँ, फॉर एग्जांपल रैंडम हमने 99% करा है, तो p इज इक्वल टू 99%.
अच्छा अच्छा. एंड व्हाट इज ये रीस्केलिंग द रेस्ट, मतलब वो
मींस इस फैक्टर से उसको वो रीस्केल करेंगे 1/1 माइनस p.
ओके.
So the pass-through is also called Franken merging. So all those previous techniques we discussed require that the model that are merged share a common architecture. Because in previous we are just indirectly we are averaging. So we want to add, or means we are averaging or adding or subtracting parameters. So the layer need to be match the sizes. So but here we can merge the different architecture of models also. So how about we means how we take bits and pieces from different models, possibly with different architecture, and stitch them together. So this time we are not averaging anything. We are leaving the weight untouched, and this is why it is called a pass-through merging. So the parameter themselves are unchanged, and what we are doing is just we can say, cherry picking layers from model A and model B, and recombining layers from different model. So this is a pass-through. Let me explain you how it's merging going using the merge kit library.
So just one thing, which among these techniques have shown the best performance?
सर ऐसा कोई आया मतलब रिजल्ट्स नहीं देखे मैंने, बट स्लर्प क्या बोलते लास्ट वाली जो है पास थ्रू, इट इज अ वेरी गुड algorithm, but also they said it is a experimental algorithm.
No, but when was the last algorithm proposed?
It is also in, I think, 23.
Okay.
Yes. So for example, if you want to merge using a tie algorithm, so we just need this config file. So in this config file, first we will define the models. So the first model is our we can say base model. So for example, here they take Mistral and model second. So it can be anything, means for same architecture. And that's, so here we are defining density. Okay. So this density means how many features are we are taking from that, means it is defining the proportions of that model. And this is also weight, means it represents the influence or contribution of this model in the final merge output. And the third model means this is a ties algorithm, so we can merge two or more what we can model. So this is, but just we need to write which merge algorithm we are using, and what is our base model, means our primary model. And then it is a parameter like when we want to normalize the, or we can say scale the models. So for slurp, here it is something different. Here we can use we are using uh, layer range in both the model, and slurp we can only merge two models. So we can see here it is a merge with slurp, and we can select our base model, and it is our t in that diagram we are I showed you t point 0.5. So it is a that value here, means it is a scaling factor, we can say. Same for pass through. It is a very simple. We are choosing the layer range from both model and just applying the merge method. So how to merge it using merge kit? We have to just install the, or we can say clone the library, and then just create a config file and save it to config.yml. And this one command is doing all for us, means it is merging the uh, models. Just we are taking merge kit yml, so it is a uh, config file of a merge kit library, and this config file is our parameter in, means we can say our config file, and this is the task we want to perform. So this is copy tokenizer, means we just copy the tokenizer from base model, or we can say source model. And this command is means we are just bypassing the things, like we can say here I have write. So this allow the process to bypass certain checks or constraints they are usually enforced. Uh, And this outside is means we divide the parameters in 1 billion bytes approximately. And lazy unpickle means we can say what we say means at the time when we want means it is for a memory efficient. We can read here means loading the parts of model or data they are needed rather than all at once. Means if we need only, then we can only load in memory. For it is for memory efficiency. So just we run this command, and it will take I think 10 to 20 minutes, and it will all download the model and merge this. After this, 1 minute. So after this step, we just store we can say save our model to Hugging Face, or I can show you the model I have. 1 minute, I will show you. So it is a model that I have tested. Means I have merged using a pass-through algorithm.
So which two models you have merged here?
Let me check. There is one Mistral from OpenPipe, and other is also Mistral. So it is, I think, a medical domain. So I just
No, but
yeah.
both are 7 billion models.
Yes, sir.
Okay, so you mean to say that this merging has happened on CPU, right?
Yes, yes, sir. But just one condition, we need a high RAM.
Hmm.
Yes.
Ritesh, what type of experiments do they conduct to show that like this merging is actually helpful, and like whatever we are ending up with is probably better than both the individual models?
इन्होंने जस्ट क्या कंपेयर करा है कि फॉर एग्जांपल हम सिंपल इन्होंने मॉडल से कंपेयर कर रहे हैं डायरेक्ट कि अगर दो मॉडल है जिनको हम कंबाइन कर रहे हैं, तो क्या उन दोनों का जो क्या बोलते हैं इसको जो दोनों सेपरेट परफॉर्म कर रहे हैं, क्या वो कंबाइन में परफॉर्म कर पा रहे क्या?
अच्छा, तो ये बट दो डिफरेंट डोमेन्स के डेटा सेट
हाँ
पे।
हाँ हाँ हाँ, दोनों
अच्छा,
मॉडल अलग
ओके,
अलग।
तो फॉर एग्जांपल वी कैन से कि मेडिकल और लीगल
हाँ,
डोमेन
मेडिकल
में
और
फाइन ट्यून
यस
करके
यस
मर्ज किया एंड
यस यस।
इवेंचुअली इंडिविजुअल पे टेस्ट कर लिया। ओके, डेटा सेट।
यस।
So can you just wait for just go to this slide again, so we can build a new model by stitching layers. So how are you stitching that? I don't like. I couldn't understand.
मीन
So yeah,
हाँ,
what is exactly happening in pass through technique?
एग्जैक्टली ये हो रहा सर इसमें कि वी आर जस्ट चूजिंग द लेयर. Okay, we are just choosing the layer and just merging. Means we are not touching the weights of a model. Means we are not averaging here anything.
No, that is okay. But suppose
Hmm.
we have picked some layers, right? Now,
Mhm.
what? How are you merging them?
Okay. So
Also,
वो मुझे
I have a
देखना पड़ेगा
question.
सर. हाँ हाँ.
In a final model, like what will be the changes? कि मतलब सेम ही एग्जैक्ट सेम कॉपी निकलेगी या फिर दोनों का पैरामीटर सम अप होके नया टोटल सम आएगा, या फिर होगा क्या डिफरेंस फाइनल में?
हाँ, मतलब दोनों का जो जो लेयर्स हम मर्ज कर रहे हैं वो दो, मतलब एक जस्ट एक मॉडल आएगा. मीन्स कॉम्बिनेशन ऑफ बोथ.
लेट्स से आई हैव अ मॉडल ए एंड बी, एक में 20 लेयर है और एक में 22, फाइनल वाले में कितना आएगा?
जितने तुम यहाँ पे डिफाइन कर रहे हो.
अच्छा,
अच्छा,
यहाँ। हाँ, नहीं, गो अहेड।
ओके, सो इट्स जस्ट अ स्टैकिंग कि एक के ऊपर एक स्टैक कर दिया है. तो
बिकॉज यहाँ पे
ऐसे
हम वेट्स.
बस
हाँ
एक ही फॉर्मेशन हो सकता है कंटिन्यूअस, एक की लेयर्स उसके बाद दूसरे की लेयर्स, दैट्स इट.
हाँ, क्योंकि ये ऐसा बोल रहे हैं कि इस एल्गोरिदम में कि इन्होंने वेट्स के साथ कुछ नहीं कर रहे हैं ये लोग।
तो
So,
ये जो दूसरा वाला मिस्ट्रल 7 भी है, उसमें क्या बस 8 ही लेयर हैं?
नहीं लेयर तो है, बट दे आर चूजिंग 24 to 32 फॉर
50
मर्जिंग।
20 32।
हाँ, वो लेयर ही मर्ज कर रहे हैं।
अच्छा, और ये पहले एम्बेडिंग और आखिरी में कौशल हेड वगैरह किसके आएंगे, कुछ आइडिया है?
वो सोर्स हम डिफाइन कर सकते हैं यहाँ पे कि हमारा सोर्स मॉडल कौन सा होगा,
अच्छा,
मीन्स
जिससे
हमारा
एम्बेडिंग।
प्राइमरी मॉडल। हाँ, हमारा प्राइमरी मॉडल हम किसको बनाना चाहते हैं वो हम यहाँ पे डिफाइन कर सकते
So
Ritesh,
Abhi, yeah. So just one thing which is not yet clear. You see, for the first one you are saying all the layers, right? 0 to 32. And for the
हैं।
second one you are saying that we are going to merge 24 to 32. Okay. But how is this merging happening is still not clear to me, at least.
यस सर, आई हैव टू चेक इट बिकॉज मैंने कंप्लीट पूरा पेपर पढ़ा नहीं था ये, सो मुझे भी देखना पड़ा।
Fine. And how much time it has taken for this merging?
सर डिपेंड करता है अपने सिस्टम पे। मोस्टली मेरे टाइम पे सर ये 10 से 15 मिनट लगे थे मेरे को गूगल खोले पे। 15 से 20 मिनट बोल सकते हैं।
And this is like a plain merging, right? You are not fine tuning the merge model or while you are merging it. No fine
जस्ट
tuning is happening at that time, right?
नहीं सर, जस्ट
Okay.
मर्जिंग
Fine. Okay.
बिकॉज दैट्स व्हाई वी कैन डू ऑन सीपीयू।
Okay.
हेलो।
यस दी।
यस रितेश की इसमें कोई लिमिटेशन होती कि हम इतने हाउ मेनी नंबर ऑफ मॉडल वी मर्ज?
नहीं इसमें नहीं है। लास्ट वाले जो एल्गोरिदम है इसमें कुछ फर्स्ट वाले में है जो स्लर्प एल्गोरिदम बताई थी, उसमें हम 2 ही कर सकते हैं। बाकी वाले में कोई ऐसी तो कोई लिमिटेशन नहीं बताई है ना।
ओके ओके, थैंक यू।
So okay, so now we will start a Proxy tuning. It is a very easy technique. So Proxy tuning is a method used to adapt large language model to a specific task or domains without modifying the underlying model weights. So this approach is particularly useful in scenario where retaining or fine-tuning the model directly is not feasible due to resource constraints, or when the original model weights are not accessible to us. So proxy tuning typically involves training a smaller model or adapting certain input or output processing layer to guide the large model's output in the desired direction. So this makes it cost effective and accessible way to leverage large pre-trained model for specialized application. So let's take an example. Suppose we have a llama 2 70 billion chat model. Suppose we have a llama 2 70 billion chat model does not exist yet. Instead, we only have a llama 2 70 billion base model. So proxy tuning allows us to get this base model to perform as well as the as well as the chat model without changing the base model's weight. So here, how can we do? So here is the steps to achieve this. First, select a base LLM, means untuned 7 billion llama 2 model, and one select target LLM, untuned 70 billion llama 2 model, and fine tune this smaller base LLM to obtain a small fine-tune LLM. Example, we can say instruction fine-tuning a 7 billion llama 2 model to get a fine-tune 7 billion model. So compute. So now compute the output difference between the base model and the tuned model, and this difference in output to the means add this difference in output to the target target LLM output, and then normalize the output, and then we can generate the answer. So it is a very straightforward algorithm. We can just subtracting and adding the
So what do
logics.
you mean by output difference? Compute the output difference between the base model and the fine-tuned model. So what is this output difference? The logics,
मीन्स
the different.
लॉजिट्स का डिफरेंस.
So logic difference, see, as far as I know, the 7 billion model has a different vocab than the 70 billion model. Is this true?
यस सर, ये मेरे को पता नहीं है इसके बारे में.
So then
मीन्स
in that case, it is not possible, right? If they have the same vocab size, then it is possible.
ओके. Okay, so any question? So that's it from my side today.